Alright, this is Andy Schweitzer, and we are going to be doing a little force of friction example. And this is again, just a typical type of problem which you'd likely to see on a physics problem involving friction. So we have our box, and the box, let's just say, has a mass of 5 kilograms. It's resting on some sort of surface that's going to create a static friction or a sliding friction. The coefficient of friction is going to be 0.3. Let's give this thing a push in this direction, and I'm just going to say my angle here is 20 degrees, so it's not representative of the actual angle, but that angle is 20 degrees. And my overall question is okay, what is going to be my net acceleration of this box with all the forces? So number one, we're going to label the forces on the picture. So I have the force of gravity going down here, force of gravity. I have the force normal right here, force normal. I have a force that's going to be applied in this direction, and I have a force that's going to be applied in this direction, and I'll talk about those in a moment, but this is your force of friction. Now, this arrow is going to be a component. I'm going to break this component up. Let's do this right here. And because we're not pushing a force directly in line with the actual object of the table, some of the component force, which is, I'm going to give this thing 50 newtons. Should have mentioned that right away. I'm going to give a 50 Newton force in this direction. So some of that component force gets put down, and some of it gets pushed forward. Some of it's not helping me move the box in the forward direction. So we want to be able to figure out what are the components of this if this angle is 20 degrees. Now, to figure out, this is some relatively simple trigonometry, but to figure out the x component, okay, and I'm going to call this force x, and then we'll call this force y. So the cosine, okay, is equal to the opposite of a triangle over the hypotenuse of a triangle, and don't forget the angle there. So in this case, I want to solve. I have the hypotenuse, I have the angle, I want to find the adjacent. So cosine of 20 degrees is equal to the opposite, okay, which in this case is going to be force in the x direction, times the hypotenuse, which is going to be 50 newtons. So cosine of 20 degrees times 50 newtons equals the force in the x direction. And to do the other side, we use the sine of 20 degrees equals the, this should be cosine is the adjacent. Cosine is the adjacent, and the sine is the opposite over the hypotenuse. Now the sine of 20 degrees is times the hypotenuse, which is going to be the 50 newtons, equal to the force in the y direction. So keep in mind the force of the x direction almost always coincides with the cosine. Force of the y direction almost always coincides with the sine. Okay. So let's go ahead and actually calculate up these values. Grab your calculator. Okay, so the cosine in this here is equal to 46 point, let's go 0.9 newtons. And of course, if you would like to make this 47, just depends on how tight you're being asked to make the numbers. And then the sine of 20 times 50 equals 17.1. So in this case, the force in the y direction is 17.1 newtons. So I must keep labeling my forces. The force X equal to 46.9 newtons. Force Y is equal to 17.1 newtons. I can label these on here. This is force X. And then there's a component that's also pushing down, which is the force Y, and that is equal to 70.1 newtons. The force of friction is the coefficient of friction times the force normal. And then in this case, we will calculate this out in a moment. Force of gravity is mass times acceleration. In this case, the mass being 5 kilograms times the acceleration of gravity is 9.8. So 5 times 9.8 equals 49 newtons. So this is going to be 49 newtons. This is 17.1 newtons. This is going to be 46.9 newtons. Okay. Let's go to step number 2. Now, step number 2 is looking at the x and y coordinates. Now, the box is not jumping off of the table, so I'm going to do my y coordinates first. They're balanced. So my force of gravity plus the force I'm applying from my applied force in the y direction is equaling my force normal. And since both of these are 49 and 17.1, simply add those two together means that I am getting my force normal is, okay, 17.1, 49 is 66.1 newtons. So I'm going to label this as now being 66.1 newtons. All right, 66.1 newtons. All right. Now let's look at the force of friction. Force of friction in the x coordinate. The box could be moving in this case. In fact, it's going to be moving. So the sum doesn't balance to 0. The sum of the forces is equal to the force applied. Now this is the x force plus the negative force of friction, which is going in the opposite direction. The force x is going to be 46.9 newtons plus a negative force of friction. Now, we have not calculated force of friction yet, so let's do that quickly. Force of friction equals to the coefficient of friction times the force normal. The coefficient of friction was given in this problem as being 0.3. So 0.3 times the force of force normal. The force normal is going to be 66.1 newtons. And 66.1 times 0.3 is 19.8 newtons. Equals 19.8 newtons. So my force of friction, and it has a negative value because it's resisting motion, 19.8 newtons. And we're getting very close to the end here of getting our net force. 46.9 is 27.1 newtons. So I subtract these two values just to get in a spot where we can see them more. The net force is going to be 27, I rounded here a little bit, 27.1 newtons. And it'll be going to the right. The last thing we might want to do, as the problem asks, is let's get the actual acceleration of the box. Force equals mass times acceleration. We got a mass of 5 kilograms. Acceleration, force is 27.1 newtons. Divide out, and 7 times, well, in this case, it's just without estimating, 27 divided by 5 equals exactly 5.4 meters per second. The acceleration equals 5.4 meters per second squared. And that is how fast it's moving, pushing down. Now, pushing down causes you to have to add your force of friction to add to your normal force. This added push down causes the friction to increase. So if someone were to pull in this direction, pull 50 newtons, that would be a different problem, but very similar. Thank you.